Okay, so this is the key to worksheet 4.4, part 4, and these are the application problems with the compound interest. All right, so number one, it says if you deposit $5,000 into an account paying 6% annual interest compounded monthly, how long until there is $8,000 in the account, and then round to the nearest tenth. So you want to find how long. So that's your time. So you're trying to solve for t. All right, so it is monthly, so it is a finite number of compounding, so we're going to use this formula. We're going to use the formula A equals P times 1 plus R over N raised to the NT. That's the one we're going to use. Okay, so remember, the P, remember, is the principal or the original amount. So you want to go from 5,000 to 8,000. So the 5,000 is your principal, and the 8,000 is the amount you want to end up with. So we're going to get 8,000, just like this, equals 5,000 times 1 plus R, the rate 6%. Now remember, you must write the rate as a as a decimal. So 6%, remember 6%, the decimal point has to be here, so you move it 2 places to the left, it becomes 0.06. So that's 0.06 divided by N. N is how many times being compounded a year, so that's monthly, so that's 12 months in a year, raised to, and then put that in parentheses, raised to the NT power. So that's 12, and then I'm solving for t. Okay, so this is what I have so far. I have 8,000 equals 5,000 times. Now since I'm solving for the variable t, which is in the exponent, let's just go ahead and write this as a decimal. So as a decimal, this base here. So as a decimal, this is 1 plus 0.06 equals, oops, sorry, messed that up. All right, 1 plus 0.06. Now 0.06 is being divided by 12, so divide by that 12, and then press equal, so I get 1.005. This is 1.005, and that's raised to the 12t power. Okay? All right, so here's the idea. My variable's in the exponent, so I need to get rid of this exponent. I need to get the variable out of the exponent. So notice what I'm doing. I want to get this variable out of the exponent, so I need to rewrite it. So to remove the exponent, to remove the variable from the exponent, you're going to take the log of both sides. Before you do that, though, this right here has to have a coefficient of 1. All right, so you need a coefficient of 1 here. So I need to divide both sides by 5,000. So next step is divide by 5,000, just like this. And so notice that this is 8,000 divided by 5,000, so they're both divisible by 1,000, so this is 8/5 equals, this becomes 1, and you get 1.005 raised to the 12t power. All right, now 8/5, let's go ahead and write as a decimal since it does terminate. So we're going to just say 8 divided by 5 is exactly 1.6. Now if it was 1.3333 and so on, I'd leave as a fraction. But since it just terminated, let's just write as 1.6. Equal, and I'm going to leave some space here, 1.005 raised to the 12t power. Okay, what I'm going to do now is just take the natural log of both sides, because remember what you do to one side, natural log or the log, it doesn't matter. You could take log, the common logarithm, or you can take the natural logarithm. It does not matter. But if you're going to try to remove the variable out of the exponent, the logarithm is what you're going to have to use. So either natural log or common log. All right, so now I can take this and write it in front. So in other words, I'm going to have this, the natural log of 1.6 equals 12t times the natural log of 1.005. Okay? All right, so then the next step is to get t by itself. So what I'm going to have to do is divide both sides by 12. See, I'm multiplying by 12. They obviously divide by 12. I'm also multiplying by the natural log of 1.005. But I do that to both sides, just like this. Okay? Now these divide out and these divide out. You're left with ones in their place. You get t equals, let me go ahead and rewrite this. That's a natural log of 1.6 divided by 12 times the natural log of 1.005. Okay, so here's what you got to do, though. You need to put this denominator, you need to put that in parentheses or brackets. Okay, so put that in parentheses or brackets because you're going to need this in your calculator. All right, so here's how you use your calculator now. You're going to say natural log natural log 1.6 divide by. Now you got to put this whole, see this denominator is two factors. You have a factor of 12 and you have a factor of natural log of 1.005. That's your denominator, so you need to put that in parentheses. So you can put parentheses, just oops, I got to divide by, and then parentheses, and then you say 12 times the natural log of 1.005. Notice you got that parentheses, you got to close like this, but then you got that outside parentheses you got to close as well, and then press equal, and you get 7.85. Okay, so my time's going to be approximately 7.85. So it's going to take 7.85 years. It will take 7.85 years for you to go from $5,000 to $8,000. All right, so it's quite a long time, but that's what it is. Okay, number 2. Notice though again, when putting this into your calculator, you got to put this in parentheses. This whole thing has to be in parentheses. Now the other way you can do it, and you may not understand this, and you're probably going to mess this up, so that's why it's a good idea to do this, is to say a natural log of 1.6, divide by 12, but then, see, you divide by 12, but then you got to multiply, see, that's 12 times, so then you got to multiply by the natural log, so you got to say times the natural log of 1.005, and oops, I messed that up. Okay. The natural log of 1.6 divided by 12, any parentheses here, then divide by 12, press equal. Okay, press equal. All right, so then say times the natural log of 1.005. God, I keep messing this up. All right. All right, so the natural log of 1.6, close the parentheses, divide by 12, okay, and then press equal, and then say divide by natural log of 1.005. All right. Okay. So what you have to do is just say natural log of 1.6 divided by 12. Press equal, and then divide by 12 again. I mean divide by this again. Okay. All right. So it's a little confusing, so that's why it's best just to put this in parentheses. So you can say natural log of 1.6 divided by 12. You got to press equal, and then say divide by this. All right. Okay. So most students see how I messed that up also. So you got to be careful. So it is best then just to put this in parentheses. Okay. So let's do the quarterly here. So you deposit $8,000 in the account, paying this to the nearest hundredth. How long will it take to get to $12,400? Okay. So you're going to use this formula again. So you want to go to 12,400. So 12,400 equals 8,000 times 1 plus the rate, which is 0.07. We got to convert that to a decimal, divided by quarterly, so that's 4, raised to the nt, so 4t. So you're solving for t. All right, let's go ahead and rewrite this base as a decimal. So we're going to say 1 plus 0.07 divided by 4, and you get this right here. So this becomes 12,400 equals 8,000 times 1.0175 raised to the 4t power. All right, now before you, remember you're trying to solve for t, and t is in the exponent. So before you can take the log of both sides, this has to be a 1 here. So let's go ahead and divide both sides by 8,000. Now 12,400, let's just see if this terminates. So 12,400 divided by 8,000, and you get 1.55. So let's just write this 1.55. So 1.55 equals, this becomes 1.0175 raised to the 4t. Okay? So I'm going to do this now. I'm going to go ahead and write this here. 1.55 equals, leave some space because you're going to take the natural log, 1.0175 raised to the 4t power. So let's take the natural log of both sides. So I get the natural log of 1.55 equals, I'll pull this out in front. I can use a property now, the power rule. I get 4t, natural log of 1.0175. Now remember, you're solving for t. You're solving for t. So right now I'm multiplying by 4. The opposite of multiplying by 4 is to divide by 4. I'm also multiplying by this. So the opposite of multiplying by this natural log is to divide by. Okay, so what I do to this side, I do to this side. Okay, now you got to put this right here in brackets so that way you don't mess up. So 4's divide out, these divide out, you're left with t. So when you put this in your calculator, don't forget the red parentheses. Natural log of 1.55 divided by, in parentheses, 4 natural log of 1.0175, close the parentheses and close. So don't forget these outside parentheses. You need those. And remember, you're not just multiplying by one factor. These are two factors down there. So that's why you need this parentheses. So if you don't put the parentheses, you're probably going to mess up, just like around here where we were messing up with when we were pressing enter. So be careful. Use at this point, put that in red. Okay, and then you're going to get the answer if you do it that way. So the natural log of 1.55, close the parentheses, then say divide, open parentheses, the red, so you get 4 times the natural log of 1.0175, close the parentheses, don't forget the red parentheses that you got to close, and then press equal, and that's 6.32. So 6.32. All right, 6.32. So t is approximately equal to 6.32. All right, let me go back over here because this said nearest 10th. So that should be 7.9 to the nearest 10th. But here they're saying nearest 100th. So nearest 100th would be 6.32. So it's going to take a little over 6 years to go from 8,000 to 12,400. Now keep in mind that there's probably hardly any accounts here that are paying about 7%. So it's probably lower than, a lot lower than that. So maybe 2% or even less in a regular savings account. Okay. Now if you're in the stock market, it may be higher depending on how things are in the stocks. Okay, continuously, let's see. Now for continuously, we have to use this formula, A equals P times e to the RT. That's what we got to use. So again, the amount you want to end up with is 12,400. The original amount you put in was 8,000. And then it's e raised to the rate, which is 0.07 t. All right. Now, again, to get the exponent, to the variable out of the exponent, we got to take the log of both sides. This has to be a 1, though, so I'm going to have to divide both sides by 8,000, just like this. And then we just figured out that 12,400 divided by 8,000 is 1.55, so you may want to, again, if it terminates, go ahead and write as a decimal, so that way you don't have too many fractions to deal with. So that's 1.55 equal, this is 1, so you get e to the 0.07t. All right, now you see how the base is e? So just use natural log. In fact, we've been using natural log throughout. But it didn't matter whether you use log or natural log for these, but for this, it is preferable. It's going to help you a lot if you take the natural log, and you're going to see why. So I'm going to take the natural log of both sides, and I get the natural log of 1.55 equals, and then bring this out in front, 0.07t, natural log of e, and here's why taking the natural log here rather than just the common logarithm helps. The natural log of e is just 1. So 1 times this is just this right here. So you get the natural log of 1.55 equals 0.07t. And see how over here you had 2 factors to deal with? 4 and the natural log of 1.0175, same thing here. Here you just have 1 factor of t, just 0.07. So to solve for t, just divide both sides by 0.07, and that's it. And so now using your, that's 1 now. That's 1. So t is about, to the nearest hundredth. See, I don't need parentheses in the denominator. I don't need parentheses in the denominator because that's just one factor, 0.07. Here, you see there were 2. That was a 4 times this. So notice I said times, so that's 2 factors. A factor of 4 and a factor of this natural log. Here, there's just 0.07. No red parentheses are needed. So you just say natural log 1.55, close the parentheses, divide by 0.07, and then, oops, sorry. So let me do this over. So you say natural, you say right here, natural log of 1.55, natural log 1.55, close the parentheses, divide by 0.07, press equal, and there's your time, 6.26. Now you should expect the time to be it would take less to get to that amount. See how this was 6.32 and this was a lower time period? It's still over 6 years, so there's not much difference. But the reason it's less is because it's being compounded an infinite number of times here. So your interest is earning interest more than the interest is earning interest more here. Okay? All right, so 6.26. All right, and so that's the end of worksheet 4.4, part 4.